Last week we looked at comfort, right? And this week we're going to look at the pink dots, right?
Yes.
Target science. And EUI is such a vast topic. I have an entire book on it if you want to read. It's such a vast topic, energy management, right? And unlike the last one, this one's going to be a lot more technical. So I just want you to be prepared for that. Every single sheet is going to have at least 2 or 3 numbers. But this, but this subject is such a vast subject. So what I'm going to try to do is try to pull that's very, very important to us that we have to remember. I only have 8 slides. So if you remember 8 points for, 1 for each slide, that's good enough. Because I don't expect every one of us to understand the complexity of EUI. I'll explain how complex it is. But we only have to remember some of these simple topics so that we can ask the right questions. Okay, everyone good? Okay, be prepared. All right. The simplest way to understand EUI is to use the analogy on cars. Miles per gallon is a common term that we all know, right? We look at the sticker price and the stickers on the car. It's the amount of energy input required for the car to run a certain number of miles, correct? We take that same analogy and apply it to buildings. It's the amount of energy required as an input to run the building for a certain number of hours, correct? So that's the easiest way to understand EUI. So the simple math is you find the total energy required for the building to heat and cool and to operate. That's the total building energy consumption. Divide that by total gross square footage. So that'll give you EUI. And as I mentioned, as simple as these formulas look like, it can be as complex as it can be. The reason is, a couple of reasons. One, back in school, we've always been taught that art is subjective and science is objective, right? You guys agree with that? But I don't. Especially energy engineering is very, very subjective. One reason, because we're dealing with climate, dealing with comfort. It is, this space can be comfortable to me, but not comfortable to Ben. So it's very, very subjective. And then the second part is we're dealing with climate. It's unpredictable. We hope we can figure out a solution based on the 30-year average, but it's not necessarily that's what will happen the next year. So it is as subjective as you can think of, because say for instance, taking a mechanical system, just a fan coil system, a lot of factors could change the performance of that system, right? Operation, weather conditions, how did they install it, are they maintaining it? So trying to predict how much energy it's going to consume is anybody's guess. So what we as an architecture and engineering profession can do is we can come up with a number of how much building energy consumption that the building is going to predicted, right, based on a certain assumptions. So this is very important. Only based on these assumptions, this prediction is true. So it is important to convey that message to whoever we are conveying.
So it's exact as long as the weather happens this way, as long as they operate this way, and they maintain it this way.
Right.
Then this number will be true, and they don't change the amount of dollars per kW or whatever it is.
Yes, so many different variables. Yes?
Is it important that we just do the composite of the building or different occupancies which have different energies?
We'll look at that next. So the unit for EUI is kilo BTUs per square feet per year. And BTUs is the unit for measurement of heat transfer. So one thing we have to understand is, I don't know, is there any electrical engineer in the room? No. They'd like to use kilowatt hours per square feet per year instead of kBTUs. That's because they're dealing with electricity alone, right? But most often, our projects will have two sources of fuel. They'll have electricity as well as natural gas. So if you don't remember anything on EUI, you got to remember these two numbers.
So 1 kilowatt hour is equal to 3.4.
412 kBTU. And the reason is, if an electrical engineer says the elementary school is 11 kilowatt hours per square feet, that's the energy use intensity of an elementary school. We should be able to figure out what the kBTU is by using this simple math. 1 kilowatt hours is equal to 3.412 kBTU. Likewise, natural gas is measured in therms. 1 therm is 100 kBTU. So these are very, very important numbers. The reason is, let's say you get, how many of you have gas at home? Okay, and what is the unit of measure for the gas consumption? Therms, right? So if you just look at your SRP or APS bill, that's not telling your story entirely. Your kBTU also depends on your natural gas usage. So if someone asks you how much my house is consuming, what's the EUI of my house, if you have gas, you should add both. So we need to know these two numbers for sure. So the gist of this slide, point 1, is you only need two numbers to figure out EUI. And off the top number, you need to make sure that you capture all the sources of energy. Okay, so far good?
So far good. You
Yes.
said total building energy consumption. I assume that means for 1 year, right?
Yes, yes, that is for 1 year, correct. Annual. So far good? Okay. All right.
So the EUI is you have a slash year.
Yes,
So is that per year? Because I have my total for my whole year.
yes.
Exactly.
So we'll talk about that now. And here are some averages for Arizona. A typical, it's easy to understand based on the need for energy on these different types of buildings, right? Prison, obviously, it's a lot of need.
24/7. So
It's a 24/7 facility. It's got a huge laundry. It's got a huge kitchen, always, right?
it's per square foot. So it's not because it's a big building.
Right, it's per square feet.
It's all averaged out.
Say, for instance, let's say you build a school campus for 400,000 square feet. It's still going to be a bunch of classrooms and little spaces. But if you do the same for a prison, the use of energy changes quite a bit, which is what we will look at in the next week.
Okay.
How these different types use different types of energy.
Gotcha.
But just as a quick refresher, these are typical projects that we do, right? So we can, right off the bat, you can qualify that the prison is the most energy intensive project.
Yes.
So, and partly the reason is, one of the reasons is it's a 24/7 facility.
It's a big
And likewise, the next biggest is office. Can anyone say why office is higher than a school? Equipment, yes.
Because
Yeah.
we cool it down so freaking cold and we
Yeah.
gotta run like computers underneath to warm us up.
Okay, that I'm gonna have to agree with Bob on this one.
I'll
And-
second that.
It's subjective.
A lot
It
of
is
artificial.
Very comfortable with that demographic.
There's a lot of artificial light.
There's a lot of artificial light, big problem, right? And there's a lot of windows too. We like windows in the offices.
And they're all single pane.
Yes.
Bob, could you expand your comfort?
Hey Bob, what cool
Okay.
factor are you using?
So this is pretty obvious. Between a high school and an elementary school, the functions change, or the need for energy changes. High school typically may have a kitchen,
And more vocational classrooms.
more vocational classrooms, and more computer labs.
Bigger people.
Not necessarily, but yes.
Most people too, isn't it?
So,
I think there are more hours in high school also.
right, and high schools may have summer usage more than elementary school. So,
So you don't start
So it's
summer
e-
school till high school?
so the one thing that the takeaway on this slide is, the next time we start doing start doing a project, if it falls into one of these things, you should be able to put it in that rank really quick. This is the average building in Arizona, 50 to 60. So we'll talk about how can we use this average numbers down the road. Yep.
Where do you get those average numbers from?
From Energy Star. And it's also from, I'll show you our buildings that we design are better than these. Okay? Okay, now let's come to your
Your
home.
assumptions, of course.
Where is, yes? Oh,
The variation, the range, I should say. How much has to do with how the building is planned? You know, all the factors that go into making it more efficient or less efficient.
that is where we come in and
Is
try
that
to
in the
take
range?
this average and bring it down. But this average is the inventory out there in the zip code in Arizona.
But, yeah, I mean, it could include the worst and the best.
It could include the worst and the best, correct?
30-year-old building,
Yeah.
not
Yes.
very insulated,
So-
facing the wrong direction,
Right.
old mechanical systems,
Based on square
very
footage.
inefficient.
Right.
All
And
that.
I'm just curious, we simply do hospitality work. What about hotels? Because they're kind of in between
Yeah.
office and prison, in
Yep.
a sense.
Hotels,
No matter format.
Depends on how.
right. And it depends. It depends on how the hotels are used. And these things, except for this one, well, let's not get into it now. We'll get into the next few slides. Your home. Let's do this calc right now. So
I did.
you know the kilowatt hours for your home for the entire year.
And,
Divide that by your square footage. What is your energy use intensity?
27.5.
Okay, 27.5.
What are you doing?
I don't know. Need to do less.
So that is, what is that? Is that kilowatt hours? 27.5?
No, I did it. I calculated to BTUs. I already did that
So,
calculation.
just compare yourself against one of these guys. 27.5. It's really
That's
good.
high.
Yeah, not bad. Mine is really worse. And
Yours
mine's-
really worked. All right.
And mine's 35.
Yours is 35.
Mine's 35 kBTU. And the reason is, it's not a problem of where I live. It's the problem of how my condo is built. About 50 to 60% of the wall that I have is all windows. It's all single pane. And I'm on the second floor. There's a lot of heat radiation. There's just no way. We don't turn the AC on at all during the day, but it still just kills us.
17.5.
That's you?
Yeah.
You're probably the lowest. I heard.
You have one bedroom.
That's 628 square feet. All the
Looks
two,
okay.
yeah, the two long walls are all CMU. I've got a CMU or a concrete ceiling, concrete floor. One of the thin walls,
No wonder he was.
one of the newer walls is up against something else, and the other wall that has windows are all shaded.
Right.
With bars.
Yeah.
Yes, with bars
With bars.
and security screens and
So, is John calculating that?
Yeah, 22.19.
Woohoo!
Pretty good.
Pretty good. Really
I
good.
guess.
But
Oh,
that's
maybe yeah.
so. Yes, we have to add gas. So, if you really want to know what your EY is, go back and add gas using those formulas.
So
Find out-
whose was the lowest so far?
Ben.
And
who's at what?
17.5.
Who's in a cave?
He lives in
Up trim trim is 30.
35,
35.
Yeah, the
I
worst.
was 22.
and she had 27.
27.
Do you have gas also?
Oh, that's a good one. Ben's always in the office, never home.
Leave it off.
So it should be 0 for Ben. Well, we'll talk about natural gas and electricity really quick in a second.
Okay,
But
you're
I
at
just-
your time limit
For the 20 minutes
content.
already?
For
No, I haven't even started. We'll
okay, I'll
improvise.
just ignore.
Thank you.
Improvise. Okay, just want to tell you.
So I just want to point out this this research that's available there, because how much of the electricity that we get at our houses is clean, as in green, not polluting? Do we know?
SRP has a lot of.
Whenever I
I don't
do
know.
it, but-
Right. And there's another way. Yes, we could know that. That's what this website is, and it's on your. This is just a short form of the parent website, but the actual link is on your homework, the quiz. So you can just follow that. Type in your zip code. It will tell you exactly what kind of source fuel is getting to your house, or that zip code, and it'll tell you how clean it is, and it'll compare it against the national average. So if you're interested, that's at a home level, right? How could we use this information for a project level? And I'm thinking, let's say we're seldom given the opportunity to choose a site for a client. Let's say a major client like Red Development or something is thinking about putting a next hotel. And if we're given the opportunity to choose different sites in different locations, geographic locations, that'll be a good thing to check. Because we can type in the zip codes of each location that we're considering and find out the cleanest zip code possible.
We sometimes do that site selection for prisons and those types of things.
So it would depend on what was served by what kind of substation. The area served by the substation
That-
will have the same degree of clean power or not, right?
Right, and that's what this database will pull up for you. If you type in the zip code.
Most corporate clients,
Uh-huh.
most corporate clients go through that.
Okay.
They look at energy consumption, what the cost of energy consumption is, plus they'll look at what the labor force is in terms of
Right.
pay. But they do pretty exhaustive search usually.
I know CCA does that.
Keep trying to
So they may look at it directly from just an energy cost because it impacts their operating budgets, but we also have to look at it from pollution. So that's what this will help us.
That's one thing they maybe don't look at.
Yeah.
They look
Probably
at
not.
the dollar value of it,
Probably
but not
not.
necessarily that.
So
They'll probably get the dirty one because it's cheaper.
right. So we'll talk.